Hello everyone. How is it going? I hope you are doing well. Let us learn about soaps and detergents. First of all, we'll understand an activity, which is activity 4.10. For this activity, we will need two test tubes in which we need to take 10 ml of water in both the test tubes. Then we have to add a drop of oil, cooking oil, to both the test tubes, and we have to label them as A and B. Then to one of the test tubes, that is test tube V, we need to add a few drops of soap solution. So that will add to test tube B. Then we have to shake both the test tube vigorously for same period of time. And then we need to observe. Once we stop shaking the test tube, we will see that the oil and water layers separately in both the test tubes. As shown in the figure, we will clearly see the layer of oil above and the layer of water downside. This we will be able to see in both the test tubes once we stop shaking the test tubes. Now we need to leave these test tubes undisturbed for some time and then we have to observe. After leaving it undisturbed for some time, when we will observe, we will see that in test tube A, in which we have water and oil. So that test tube will have the same observation, which means oil and water layer we will see separate. But in test tube B, in which with oil and water we also have added few drops of soap solution. In that we will see that it is dissolved in water. What is the conclusion for this activity? This activity demonstrates that the effect of soap in cleaning. We all know that most dirt is oily in nature, right? Oil does not dissolve in water. That we all know, and by this activity also we learned. But when we have added soap solution to test tube, it dissolves in water. Oil drops will dissolve in water. This way, cleaning of clothes takes place. So this is the simple activity to understand the cleaning effect of soap. Now let us talk about soap which we use for washing our clothes. Soaps are carbon compounds as we have discussed in the beginning of the chapter. What are soaps? They are fatty acids. Of what? And they are long chains of hydrocarbons and carboxylic acid attached to it. Soaps will be salts of fatty acid. And fatty acids are what? Long chains of hydrocarbons. What are hydrocarbons? Compounds of hydrogen and carbon only. So this will be salts of fatty acid, long chains of hydrocarbons with what is attached? Sodium or potassium is attached to it. So here we can consider that long chain of saturated or unsaturated compounds, and at the one end sodium or potassium will be attached to it. I'll give you name of soap. It is sodium stearate. You will remember this name. It is sodium stearate and the chemical formula of it is C17H35 COONA+. As you can see, carbon are 17 and H hydrogen are 35. So we can imagine that how much long the hydrocarbon chain is, right? So we will see that the molecules of soap look like this. This is one molecule of soap. So the molecules of soap are what? Sodium or potassium salts of long chain carboxylic acids. Now let us understand about soap molecule. This is one molecule of soap. You can see how the structure is. It has two ends. So the upper portion like circle, that is head, and tail, that is another end. Okay, so head is hydrophilic end and tail is hydrophobic end. So this is the structure of soap molecule which we all remember. Let us understand it in detail. The head, which is hydrophilic end. Hydro means water. Philic means which is attracted towards water, which loves water. So from the word itself, we will remember that hydrophilic, which means which loves water. The tail, that is hydrophobic. Hydro means water. Phobic means phobia, right? Fear. Which means this tail has phobia of water, fear of water. What does that mean? This ant is not attracted towards water, but it is attracted towards germs. Okay, so we will remember that hydrophilic ant loves water and hydrophobic ant loves germs. So this way we will remember the structure of a soap molecule, hydrophilic ant and hydrophobic ant. And by combining number of soap molecules, a structure is formed which is called Micelles. In this figure, you can see on the left hand side one soap molecule is shown, that is fatty acid molecule, soap molecule. Head and tail are shown. So when these type of number of molecules combine together, it forms the structure which is called Micelles. Okay. Now let us understand formation of Micelles and how it is helpful. As we have already discussed that soaps are molecules in which two ends are there. One is hydrophilic and another one is hydrophobic. Hydrophilic, that is attracted towards water, and hydrophobic, that is attracted towards germs. That we can consider it as oil or dirt. When the soap is at the surface of water, as we can see in the figure, what happens? The hydrophobic, which is tail of soap, will not be soluble in water, and the soap will align along the surface of the water with ionic and in water, as you can see in the figure. As we all know that the hydrophobic ant, which is attracted towards germs, dirt, oil, so they will not be attracted towards water. So what happens? They all will be collected towards the dirt and germs, whereas the hydrophilic head, they are attracted towards water, right? So they will form this circle like structure, which means they align along the surface of the water, whereas all other tails will be in the water. And inside water, these molecules have a unique orientation that keeps the hydrocarbon portion out of the water. And because of that, all the hydrophilic, which are ionic ants, are on the surface of the cluster. And this type of structure is called Micelles. What is Micelles? the soap molecules which form the structure called micelle, in which one end of the molecules is towards the oil droplet or towards the dirt, and the ionic end, which is the hydrophilic end, that faces outside. This type of structure is called micelles. By this figure, we can clearly understand that micelle is the structure where all the ionic ants, which means hydrophilic ants, they are on the surface, whereas other end, which is hydrophobic, that all ants are attracted towards dirt or germs. This formation is called micelles. Now, soap in the form of a micelle is able to clean. Why? Because the oily dirt will be collected in the center of the micelle. As we have seen that all the tails will be attracted towards the dirt. So this way, all the oily dirt will be collected in the center of micelle. The micelles stay in solution as a colloid and will not come together to precipitate. And these micelles will not become precipitate. It will be colloid. Now we all know what is precipitate, right? Insoluble in water. Whereas colloid means what? They are somewhat soluble in water, but we cannot see with our naked eyes, right? This is the reason that the dirt which is suspended in the micelle, that will be easily rinsed away. The soap micelles are large enough to scatter light, hence a soap solution appears cloudy. Why? Because micelles are colloid. They are not precipitate, they are colloid, and we know colloidal solution scatter a beam of light. That is why soap solution appears cloudy.